In this video, we're going to edit our AI FSM to allow the AI to wander around the scene randomly. It can then go back and forth between a random wander and a pursuit of the player. So let's get started. First step to this is to add a new state to our FSM that will allow us to calculate a new random position. So make sure that you've selected your AI object. In Playmaker, we're going to add state. We're going to name this new random position. Now, in this new random position state, we're going to calculate a new vector 3 that's going to be the position that we're going to move towards. To do this, we're going to calculate a new x position and a new z position. We're not going to calculate a y position, as we don't really need to. Most terrains are fairly flat, and the way we're going to do it is going to work no matter what. First thing we're going to do random float. So let's add that to our state. We're going to add that twice, once for the x, one for the z. Our minimum values are going to go from -1, we're going to go up to a maximum of 1, and same for the second one. This first random float will work for the x coordinate, the second random float will be for the z coordinate. We need to store these values, so let's create those variables. Go over to your variables window, create a new float, x coordinate, and another z coordinate. Back to your state, and we'll store those values. Next, we need to take these values and turn them into a vector. So in our action browser, we're going to look for vector 3, and we're looking for this action here, set vector 3 x, y, z. We're going to set the x value to the x coordinate and the z coordinate to the z value to the z coordinate. The y coordinate we're going to set as 0. So hit the equal sign and let it be 0. We need to store this new vector, this variable. So let's create that variable. We're going to call this random position. Save it as type vector 3 and add that. Back to our state. We can store the random position. Now, we need to make sure that this vector has a unit length, or length of 1. That way we're able to take the same size step every time. Or another way to look at that is that the position that we're going to move to is the same distance away each time. So we're going to use this command here called vector 3 normalize. We're going to put in the random position. And that's just going to take this vector and make sure that it's a unit length, or length 1. Now, we may not just want to go 1 unit away. We might want to go a set distance away. So we're going to use this command, vector 3 multiply. Add that in, make sure it's at the bottom. And we're going to take this new vector that's length 1, and we're going to multiply it by something. And then it's going to be that length. So we're going to take this random position, and we're going to multiply it by a value. Now I could just type in a value here, or I could create a variable that'll be my wander distance. So let's do that. Variables, wander distance, add. Now I'm going to set that value, let's set it to 5 for now. I'm also going to click this button here, Inspector. That'll show this variable in the inspector for our FSM, so I don't have to come into my FSM to change that value. I'll have access to it in the inspector. Back to your state. Come down to the vector 3 multiply, equals, and we're going to choose the wander distance. Now we've taken this random variable, these random variables, made a vector, normalized it, and then multiplied it by a given length. Last thing we're going to do in the state is add the command next frame event. This will just wait 1 frame and go to the next state. We don't need to call it anything special, so we're just going to add the transition, finished. And then the next frame event, we'll call that finished event. That's all there is to that state. Now we need to take this random position and set our nav mesh agent's destination to this new random position. So let's create a new state and call this set destination. Oh, I've already used that name, so we'll call it set random destination. We can't just simply set the nav mesh destination to this random position. This random position needs to be a little ways away from where our player is. So what we actually need to do is get our player's position and then add this random vector onto that player position. That way we get a position, a random position, that's just a little ways away from where we already are. So in our action browser, we're going to get position, we're going to use the owner, and then we're going to store this as player position. And then in our action browser, we're going to search for a new command, vector3 add. Again, move it to the bottom. What we're going to do is take this player position and add to it this random position. So we're going to take that random position and add the player position. Now, the way this action works, it's going to take this random position, add the player position to it, and then save it all as random position. Now, before we go any farther, we now have a random position where we want to send our character to, but it's possible that that random position is off the nav mesh. It could be off the edge of our plane. So we need to check and make sure that this new position is in fact on the nav mesh. To do that, it's going to take a couple steps. We need a new action that's going to sample the position. By default, Playmaker doesn't have that action built in. So we're going to need the Playmaker eco browser. So if you don't have this installed, you can go up to Playmaker, add-ons. There's an option here for download add-ons. You can see I already have mine installed. And I go to download options. And that's going to open up a web page that looks like this. First option here is ecosystem browser. Click on that and it'll download a Unity package and you can install that. Once you have the ecosystem browser installed, go back to your Playmaker menu, add on ecosystem, and then ecosystem browser. That'll open up a new window, and here we're going to search for pathfinding. This is a package, several different actions that relate to the nav mesh agent and the nav mesh itself. As you can see, I already have mine installed. So click the import button, and when you're done importing, you'll have the command that we need. Go to the action browser, and we're going to look for sample position. And the command we want, the action we want, is the nav mesh sample position. Double click to add that. Make sure it goes to the bottom. Now the way this works, we're going to give it a source position. We're going to give it a position that we're going to try to move. And it's going to check and see if that position is on the nav mesh. And if it's not, it's going to give us the nearest position on the nav mesh to the position that we gave it. And this max distance is the maximum allowable distance between the source position and the returned position on the nav mesh. For our purposes, 10 should work. So we're going to give it the random position. It's going to check and see if that's on the nav mesh. And then down here, under hit information of the sample, it's going to output a position on the nav mesh. I'm going to set that to random position as well. So we're going to input a random position. It's going to check and see if it's on the nav mesh. If it's not, it's going to return a new value and save that as random position. Last step, we need to take this random position that we now know is on the nav mesh and set our nav mesh agent's destination to this new position. So then in the hierarchy, make sure you're on your AI object, go to the inspector, and drag in the nav mesh agent. We're going to set property. We're going to set the destination. Do a vector3. We're going to hit the equal sign so we can set it as a variable, and we're going to set it to this random position. And that'll do it for this state. Well, actually, let's add one more piece to this. Let's go back to our action browser. We're going to add next frame event. Make sure it goes to the bottom. And again, this is just going to wait one frame before we send an event. We're going to add a transition finished and put that into our next frame event of finished. Now we have our two actions, or rather our two states, one that gets a new random position and another that sets the random destination. So if we integrate that into our FSM, if we look here where we're checking our values, the values are false, meaning we can't see the player or we're not going to pursue them. That'd be a good time to go get a new random position. Get the random position, we're going to set that random destination. We then set that random destination, we're going to go back and check our values. Hey, can we see the player now? Can we pursue the player now? So let's see what happens. As you can see, our AI is kind of moving around, but not just kind of jittery all over the place. Not really what we want. The problem is our AI never gets to its destination because every frame or every couple of frames, we're giving it a new destination. So what we need to do is add in a distance check, and we'll do that next. So our next step is to add in a new state that's a distance check. So let's add in that new state, name it distance check. First thing we need to do is get the player position. Get position. We're going to store this. We're going to store this as a new variable. So we're going to go to variables. We're going to call this current position. Oh, let's make sure that's a vector 3. Go back to our state and store it as our current position. Now what we want to do is compare this current position to the random position that we're trying to get to. And unfortunately, Playmaker doesn't have a built-in way to compare vector 3s or positions. So what we're going to do is take our current position and subtract the random position. If what we get is essentially 0, then we're right on top. But realistically, we're not going to get 0. We're going to get a new vector, and if that vector is small or short, then we're pretty close to a random position. If it's not short, we're not very close. So let's go to our action browser, go vector 3, and use subtract. Double click or hit enter to add. Sure it goes to the bottom. We're going to take that current position and we're going to subtract that random position. And the next action we're going to use, again, is a vector 3. And we're looking for length, or vector 3 length. I want to get vector length. Equals, and we're going to get a length of this current position. And we need to store that as a float variable. So let's go create the new variable, variables. This is going to be current distance, or current distance to our target location. It's going to be a float, so we're going to add that, go back to the state, and we're going to store that as current distance. Now if this current distance, again, is small, we want to get a new random position. If that current distance is large, we want to keep moving to this current random position. So go back in your action browser and you use float compare. And we're going to compare this current distance variable to something small. And I mean something small because there's not an exact value. How small it is depends on the size of your AI character. If your AI character is very large, we need to compare this to something larger. In this case, I'm going to compare it to 1.5. That's about right. In general, you want something a little bit taller or a little bit bigger than half your character's height. Now again, if current distance is less than 1.5, we want to go to a new random position. If it's greater than, we don't want a new random position. So we need to create 2 new events. Let's go to events. We're going to create one, get new random position, and another one, too far. We're still too far away. We're going to add those transitions to our state. Come back into our state and our float compare. So for less than, we're going to get a new random position. For greater than, we're saying, hey, we're still too far away. We don't want a new position yet. Now, it's really unlikely that the current distance is going to be exactly 1.5. But just in case, we're going to assign get new random position if they're exactly equal. Now let's make some connections in our FSM. So if we get new random position, We're going to connect over there and get that new random position. If we're too far away, we're going to come back and update our Boolean values to see whether we're ready to pursue the player or not. A little rearranging. Now we need some way to get to this distance check. And so what we're going to do is, after we check our values, if those values are false, meaning we're not going to pursue our player, we're going to come here and check our position. So let's see what happens. I push play, and not a whole lot's happening. It's kind of buzzing around. And the reason that is that the new random position that we're trying to get to, by default, is going to be the vector 0, 0, 0, which may or may not be a long ways away from where we are. So what we need to do is have this new random position be our start state. So every time this FSM starts, we're going to get a new random position. That kind of makes sense, as we're unlikely to be pursuing our player on the very first frame. So click on this state, and right-click, and set as start state. Let's see what happens. We can now see that our AI is wandering around the scene. You can see in the scene view, the debug, the raycast, and the radar are all still working, and we're moving around. Now if I get close to my character, it's good, or close to my AI, it's going to start to pursue, which is great. But if I run away, it gets locked in this cycle. So we need to add something else. We need to check our destination, and we'll do that next. So the problem is our FSM has two loops. The loop on the right is trying to move to the destination that is the player. The loop on the left is moving to a destination that's random. And this distance check is simply checking to see how far away from that destination we are. Well, if we're trying to move towards the player on the right-hand side, we're going to be a long ways away from a random position, or most likely. So what we need to do is add one more check in here, and that is to check our destination. What we need to see is the navmesh agent's destination, the random position, and if it is, great, we'll keep doing a random loop. If not, we need to get a new random position. So we're going to add a state. We're going to call this check destination. And in here, we're going to get the destination of our navmesh agent. So go to the inspector, making sure that you're on your AI in the hierarchy, drag the navmesh agent into the state, and we're going to get property. The property we're going to get is the destination, and it's going to be a type vector 3. So we need to be able to store this. We're going to create a new variable. We're going to call it destination. That's going to be a type vector 3. Add that, and back to our state. Store this as our destination. Now again, we want to compare this destination that the navmesh agent is trying to get to with our random position. Are we actually trying to get to the random position? Or not? So we're going to use our subtract trick again. We're going to go to Action Browser, vector 3, subtract. We're going to take the destination and subtract the random position. And again, the vector that we get, if it's short, then we're trying to go to our destination. If it's long, we're not trying to go to our destination. Or rather, if it's short, we're trying to go to the random position. If it's long, we're probably trying to chase the player. So we're going to get the vector's length. So go to the Action Browser and search for get vector length. Add that. Equals, and we're going to get the vector length of this new vector 3 destination. We need to store that. Go to variables, create a new variable, and call it distance to destination. It's going to be a type float. We're going to add that. Back to the state, store this vector length as distance to destination. Now we need to do a float compare. So again, if this distance is short, that means we're trying to get to our random position. If it's long, that means we're probably looking to get to the player, in which case we need to get a new random position. So action browser, search for float compare. We're going to compare its distance to destination, again with something small, 1.5. Could probably be smaller than that. And then we're going to need some transitions. We're going to have one that goes to a new random position and one that goes back to a distance check. So we don't need to create new events. We can use ones we've already created. We're going to add transitions, get new random position, and too far. Back into our state, our float compare. If this distance to destination is small, we're going to continue in our loop. If it's a long ways away, meaning we were probably searching for our player, we need to get a new random position. So if it's greater than this, we're going to get a new random position. It's less than, it's too far. And again, we're going to do the equals just in case. Make our connections. There we go. Now, we need to make one more connection here. When we check our values and those values are false, we want to come up here and check our destination. So we're going to make that connection there. Rearrange a little bit to make it easy to see. And let's see what happens. Our AI is still wandering around the map randomly. If I come in, close to it, the AI will now chase the player. Now the AI can no longer see the player, and it's wandering around again. Come in close, pursues, chases, and once the player's a long ways away, the AI goes back to wandering. And that's it. We now have a random wander.